Welcome to Maths with Bob. Today we're looking at finding the equations of tangents and normals to curves. Now you can see here there's a few things you do need to know. One of them is, first of all, you need to know how to differentiate, and differentiate the curve especially. You need to know that there's a gradient relationship between the two lines, well, the tangent and the normal, and in fact that is that m of the tangent times m of the normal is -1. The same thing for perpendicular lines, because the tangents and normals are perpendicular to each other. And you also need to know how to find their equations using the equation of a line form called the point slope form of a straight line, which is y minus y1 equals mx minus x1. Here you can see m is the slope evaluated at that point x1, and the y1 value is in fact the corresponding value to x1 on the curve. Okay, so let's have a look at an example. Okay, here we have a question which says find the equation of the tangent normal to the curve at the point. Okay, so first up, what I always like to try and do is draw up just a picture. I always like to try and draw a picture. Let's have a quick look. What would that be? Okay, so we know that, okay, if you have the y and the x-axis, you know the roots would be at, say, 3. So over here at 3, and one at -4 over here, say -4. And you know it's a parabola, so it's actually coming down like this and coming back up like this. Okay, so that's the first thing. Okay, x is equal to 4. Where would that be? Well, you can see here 4 is over here. Let's quickly go up to the curve. And actually, let's put a point there. Now, we don't know what that point is, so we're going to need to find that point there when x is 4. So let's plug it in. 4. Okay, if x is 4, we get 4 and 4 is 8 times 4 minus 3, which is 1. So we know that this value here, over here, okay, is in fact 8. Okay, so we know its y value is 8. So that's the y1 value, and the x1 value is 4. Now, let's actually try and also draw a picture of what's happening. We are going to find the equation of the tangent, which is this line here, and the normal here, okay, which is at right angles to it. So this is the normal, and this other one here is the tangent. Okay, so we need to find the equation of both those lines. Okay, so how are we going to do it? Well, the first thing, I mean, we could differentiate this particular curve and y. Okay, here it is. We could differentiate it and actually by the product rule, or I think I'm just expand it out and just differentiate it as it stands. So first thing is, we'll just rewrite y. Y is equal to, you can see, expand this out, x squared. Now, what'll be minus 3x plus 4x, so it's just plus x, and minus 3 times 4 is minus 12. Okay, 12. Okay, so the derivative, or y dash, dy dx, I just write it as y dash. You can see here is just 2x plus 1. Okay, okay, so that's the derivative of that particular curve, or the gradient function for the curve. Now, I need to actually evaluate this when x is 4. So if I actually get, let's have a look. So y dash when x is 4. So y dash at the value 4 is going to be 2 4s are 8 plus 1, 9. Okay, so we know that, in fact, the gradient, if you like, of the tangent at that point is 9, or the slope of the curve at that point when x is 4 is in fact 9. Now, so we know that that's the m value for the tangent. Now, we know that the negative reciprocal, which is minus 1/9, will be the slope of the normal. So let's actually just write in what these would be. So, okay, so what here? What is the slope of this one? The m of this one is equal to 9. Okay, what's the m of this one? The m of this one would be equal to minus 1/9. Because when I multiply those two values together, 9 times minus 1/9, we get -1, i.e. there's a relationship between the slopes in that they are perpendicular. Okay, so let's actually now find the equation of the tangents and normals. So the equation, okay, equations. Okay, first one is, say, the tangent. Tangent. Okay, y minus y1, so it's going to be y minus, okay, plugging it into this form, y minus the y value would be 8, okay, equals the m, which we know is 9, okay, and it's x minus the x value, which we knew we were given actually was 4. So we rearrange this. We can see here y is equal to, 9 lots of x. Now we have, minus 4 nines are 36. 36 plus 8. Now it's actually minus 36 plus 8, so it's going to be negative 28. Okay, so here we have the equation. That is the equation of that tangent line. Okay, so if you like, you could say this line here, okay, that equation, okay, is of the tangent over here. That's its equation, right? So let's have a look at now the normal, okay. Okay, so the normal would in fact be, let's have a look at normal. Okay, let's plug it in again. Y minus y1, okay, the y1 value is the same, equals, now it's minus 1 on 9. Okay, the gradient is a negative reciprocal, x minus 4 again. We know that the y value is 8, and the x value you see here, which we're given before, the x1 value, if you like, is in fact 4. Now, if we multiply everything by 9, we'll end up getting, let's have a look, 9y minus 9 eighths are 72 equals minus x, and then we get a minus times a minus is a positive 4. Okay, so I normally put everything over one side, and we'll write this one in general form. Okay, so put the x on the other side, so we have x, okay, plus the 9y is still there, and then we add, well, okay, well, we'll move the 4 across, so the 4 becomes negative, and we end up getting, minus 76 is equal to 0. So this is now, this bit here is in fact, this is the equation of the normal. Now, where is the normal? Well, you can see here, this is the normal here. Okay, this is the equation of this line here, the normal. Okay, so the tangent, remember, we worked out the tangent's equation was in fact over here. Okay, we've got this in y equals mx plus b form. You can see here this is the point, the slope-intercept form, and the other one is in fact called the general form of the line. So we've actually got two versions of the equation of the line here, written in different ways. Okay, well, thank you for watching. We'll have some more videos later. Thank you. Bye for now.